Alright, we're going to start on the second part of this. We kind of wrapped up the other section. Before I get into it, I want to take a second. I want you to, I don't have a slide on it that represents it very well. So I want to talk a little bit about cascading. So it'd be page 4-28, and we look at cascading sequence versus block sequence, backstep sections, other things of that nature that help us. Surely we will talk about this here. We talk about it later, so let's start here. All right. Same thing we hit earlier with, just starts up very again really quick. Brief introduction of it. AWS systems used all over the world. They were the original ones. There are also some ISO standards, which can be a little bit different. Some of the symbols in there as well. Okay. Depends kind of on who your product is. ANSI approves both. But typically in the US, you'll see ANSI, and in Europe and other places, you'll sometimes see ISO standards. Quite a bit. Naturally, the global manufacturing, the way it's going, we're starting to see a little bit of both all the time. And they're actually doing a pretty good job, especially with today's CAD programs, of making sure that they've got both on the print. Kind of like a metric or inches, a lot of times you'll see two different versions on that print. It doesn't take them a lot to convert it over. I'm sure 20 years ago, well, even 10 years ago, that was a much different situation. It took quite a bit of work to be able to convert everything over from millimeters to inches and so forth. Okay? Now not so much with the new software. All right. Standard welding symbols. So welding, brazing, non-destructive examination, same thing. Now we're getting into the actual symbols. Before we were kind of talking about weld joints and parts of the weld, basically the prep and how we do that. Now we're going to be concerned about how we fill them up, and the welding process are part of this at this point. Okay. Weld symbols, you can see all your top ones, your main views. Your main common ones, specifically your square beam bevel, right? Those are the three that we use most commonly. Scarf, you're not going to see a lot, but every once in a while you will see this scarf associated with, when we talk about chapter 3, brazing, particularly because we get a lot more surface area at that point. Okay? Certain thin materials that are done by oxyacetylene welding as well will also give us a scarf symbol. So again, these are the weld symbols, not necessarily the welding symbols, the smaller portion of it. And then we actually get into, this is our prep, what type of joint it is, right? We just talked about these, but then what type of weld are we going to use to fill up that joint prep? Okay? So, these ones here can be confusing between seam, spot, or projection. Again, I don't know that I've ever seen a projection weld. I do see seam, and the way I think about it is think of those railroad tracks, and I talked about the rollers going down. That's how they track those on the seam welds. But the stud weld will always be underneath, okay? It's always underneath the line. It's never centered, it's never above, it's always underneath the line. It always has been underneath the line. Of course, unless you take the blueprint and turn it around this way, then it's on top of the line. So 6 has become 9, and so forth. All right? All right, so think about which way you're looking at this blueprint as well. Most of the others, it doesn't really matter. I've seen surfacing both directions. And the reason I say that is because it's going to matter a lot of times whether it's done from the arrow side or the other side. It's going to specify that portion of it. Okay? Stud weld usually doesn't tell you that, it just shows you the fade surface of where it is, and that's where it's going to be. It's pointing, it's almost always on the arrow side, it's pointing to the surface you're going to be fixturing the stud to. Okay? So, real quick, all symbols with a perpendicular leg. So, example, a fillet weld. A fillet weld is always drawn with a perpendicular leg on the opposite side. Okay? Meaning, your fillet weld will always look like that. It will never look like that. Okay? All right. Let me get rid of that green one. It's kind of the other portion, again, this one tells you that surfaces are to be below the weld line, but I have seen them drawn on the top side of the weld, of the line for surface welds. Never stud, but I have seen them. Doesn't mean they're right, but I have seen them happen. In that direction. Okay. This is the symbol we've got in the shop. Take a picture of it. You write it down, and this is your recipe. You can figure almost anything out from this portion alone. Just process of elimination. Okay? Again, actually our weld, arrow side, other side, finishing contour, the actual groove angle, and then the root opening in this section, number of spot seam welds, elements in this area being shown. We get into this also, it might tell you, like on a plug weld, remember I talked about a fillet welder, it might show you it's halfway full or half depth. Sometimes it'll tell you here, underneath this, half full instead of the size of the fillet weld. So the size would be here, maybe a ½ inch fillet weld on a plug weld. This, it would tell you, a lot of times it can tell you half or 50%. You're going, what in the world is that? It means fill that plug weld up roughly halfway. So 2-inch thick liner, fill it up 1-inch weld, okay? Particularly things used in road equipment and stuff like that, you'll see from time to time. The fill build symbol, doesn't matter whether it's filled in or it's not, okay? Sometimes I've seen them filled in, sometimes I haven't. I went back to research, but there's nothing that says if it's black, it's different than it is if it's clear. Does not matter, it's still a fill weld, okay? Weld all around, naturally, length, pitch. So here's what I was talking about before. If it only has one of these, it's not in parentheses, it tells you it's the depth of the bevel, the size, or the strength for certain welds. So if I'm going to do a complete joint penetration weld all the way through a 1-inch plate, this weld is going to, that number right there is going to be 1-inch plate. If I'm doing an incomplete joint penetration weld, and I want to leave a 1/4 inch at the bottom, then this weld is going to tell me 3/4 of an inch, and this groove weld, or sorry, this is going to tell me 3/4 of an inch, and this groove weld side is going to be maybe 3/4 plus 1/8, because it wants a root penetration. So I might tell you 7/8, and then that's going to be the depth of your bevel. Okay. I say that right? I hope so. We're going to walk through it later on too. Okay. As we go through this. Most details, like specific details, are going to be in the tail. And even in the tail, you don't see a lot of details. It's going to give you a reference on the print. See detail A, see detail B, mechanical drawing A-B, whatever else. That's where you're going to find most of the details out of. But that's where you're going to see things like consumable inserts, electrodes, processes, things like that as well. Okay, especially if there's multiple within one print. Or there's a welding specification for sure, or your choice, I mean. Arrow notation, so the two things it definitely needs is a leader and an arrow. Okay. Both of those sides of that, one side, the bottom side is the arrow side, the top side is the other side. So this is a great example of a square groove plate. The piece it's pointing at, arrow side, or in this case it would just be a square groove weld here. The other side of the actual weld joint. T-joint gives you a good example. This one is a direct reflection of over here. Arrow side is of this one as well. Okay? So here's a perfect example. arrow side, single bevel groove. It is, what's that broken line mean? A break is actually used when you're pointing to the actual piece that needs to be prepped. So if I break this, it's a single bevel, and I just point straight here, that tells me that this one needs to be prepped. In this case, it would be on the top section. And this is really common, especially on a vertical plane, right? So you're gonna be doing a horizontal weld. But if you're putting a sheet of plate down like this, or say a pipe or a box tubing around that, you're gonna usually do the bevel on the top side, because gravity's gonna pull it down here on the bottom, so you wouldn't want a lack of fusion going this way, okay? You'd be trying to fight to get up here to get to this top edge. So this is working for the welder, less discontinuities and so forth. And there are some times that this can be pretty finicky, okay? As far as making sure if that line is broken, it is pointing to the edge that needs to be done. 2 more arrows may be used for a single reference line. Oh, come on. Sure enough, doesn't have one. So 2 more arrows might be used. See if I can give you a good example. There was one here on the book. Maybe it's a different one. I might see that the art book that it's shown. But, sorry. Box tubing, right? Up to a faned surface. Say this goes through this plate. So this is from the top view. Let's look at it from a side view. Right, now is it starting to make sense if you look at it? This plate comes in and ties into it here. Right, so at this point, these, and then, right? So say this situation here, you're looking at this weld joint, you might have an arrow that says something along the lines of this. And it's usually not going to break that way. But you can't weld this front face, right? So you can't use a weld all around symbol, because you don't want to go all the way around it. There's no reason to. So in this case, you can only weld this from 3 different directions. And that is typically when you'd see a multiple arrow situation. So if you see a multiple arrow situation, you got to look at your geometry. It might be a little more complex than you thought. Or just say, oh yeah, all the way around that thing is unacceptable. I can't really do that. So other than that, if it were in the center of this piece, right in through here, then it would be really simple. You know, absolutely. Just tell you weld all the way around, you weld all 4 sides all the way around. Okay? That's typically when you're going to see multiple arrows. Okay? And I've also seen, say, grading or roofing on top of something. We put plexiglass or a fall-over protection system to where you had to weld on the top in multiple sections. So you'd say give a 2.5 pitch or something, 2-inch weld every 5 inches on center, work your way around. And then on the underside, they only want you to do it on a couple places, maybe do a plug weld. It might actually point to the 3 places that they want you to pick out. Okay? All right, the tail, again here, GTAW, gas tungsten arc welding, AU, austenitic, okay? Bottom one is typical in 5 places, so this would be say it gives you a stitch pattern, just like I talked about in a ROP system. You want a 2-inch weld every 5 inches or every 12 inches. Say it's only 6 inches, or it may not even give you a pitch. Just give you a number of welds, 6, and then just say typical in 5 places, right? For some of you that have done the SolidWorks drawings and some of the other CAD stuff, you know, you could say that might be, the radius might be 10, but it might be in 5 places. You've got that same radius there, okay? Arrow side weld symbols, naturally, all in the bottom section. The bottom one is broke, so it's actually pointing at the member that you would want to make sure you were doing a single J groove preparation on, okay? Other side welding symbols, exact same, just opposite side, all right? So sometimes it can be goofy thinking about arrow versus top side. So, particularly here, it straddles the line when there's no side significance. Doesn't really matter in this case. Spot weld and seam weld are good. This is a flash weld down here. I've seen this happen on thin material. Sometimes it'll just be a square butt groove from there, and it might give you a speck here on the arrow side. And I usually try to follow the print to say, hey, it needs to be welded from the arrow side, specifically coming down. But say it's real thin gauge metal, does it matter? Sometimes it doesn't. Sometimes it does, sometimes it doesn't, right? You kind of have to look at the geometry and say, does it matter which side it's coming from? Specifying the weld needs to come from here. But in this case, if it doesn't give you any dimensions there, it just needs to be a square groove butt deal all the way through. Assume thickness of material, and it's not specifying from which direction either, okay? All right, these ones start to give you the dimension naturally, toe to toe. We've had this conversation multiple times in the shop. Again, left perpendicular leg, arrow side, 5/16 of the weld, so it's on this one. If it were on the top side, we move this over to here. This is a good example, showing you specifically here. And this one's really hard because a lot of times I want to think, like, you have to look at the geometry of the part too. Because typically my first instinct is this is going to be the 1/4 inch weld, right?
Yeah.
From here to here, because everything else I'm looking at is a T-joint, but it's actually the 1/4 inch weld is here instead. So arrow side, other side, arrow side of 5/16, other side of 3/8 in this case. Okay?
So this guy's 3/16, 1/4, 3/16 here, and since it's still one plate, the 1/4 is on the other side.
So I want you to think, without tearing it up, that would be the T-joint, just on the side, correct? Typically, if we look at it, we're usually thinking of the T-joint going that direction. So this is the piece of material, and this is where your mirror bracket or whatever else is welded onto. Okay. Usually, when you look at the part and you look at this, it makes sense. Sometimes when you're just looking at the print or the welding symbol, it can be rather confusing. Fill weld dimensions. Again, not everything has to be spec'd 100%. True 45, exact same sizes, and it doesn't have to be a complete joint penetration as well. So this would be very typical of exactly what I said. Say you're working in a shop or a concrete floor, very thick, you work on heavy equipment or large materials that are coming in, and you just have a bracket, you know, an air hose bracket coming up, right? But it's 20 feet in the air, so forth. It's not structure bearing, it's just a pole, but it does have to have some support going up there. You might see something very similar to this, where the majority of your weld is going to be focused on the bottom plate and just a small weld on the top section, okay? Very seldom do you see it, but occasionally it can happen. It usually happens when you're tying in large or thick equipment, or, thick or large members of steel, and then attaching a small piece onto it as well. Because if this is 1/8 inch material, and this is a 1/4 inch weld, then our weak link is our actual material, right? So we need to make sure that we're thinking about that. We always judge the smallest piece. The best metaphor you can use for this is imagine two big battleship chains, right? I mean, they can be this big around, holding all this big heavy anchor, but if they're tied together with baling twine, the baling twine is the weak link. It doesn't matter how strong the rest of it is. We always measure the weld size by how small, or the smallest size of the weld, the smallest piece of the weld, because that is the weak link, okay? But usually when it does this, if it's going to tell you this, it will specify which one is to have the heavier weld size than the other one. And it's important for you, if you're writing out a print for somebody, that you specify that as well. Just don't say 1/4 by 1/2, okay? You need to make sure to be very specific which one. Because not everybody's going to understand or have your knowledge of this stuff by the time you get out there. My experience with half of this is most of your foremen won't understand half of it by the time you get out there. You'll have more knowledge as far as prints, procedures, and everything else than most of the people actually running shops. I wouldn't say running them, but maybe overseeing the day-to-day operations of certain things as well, okay? This is usually when we start to deal with the engineering portions of it. Fill weld dimensions. So again, length versus pitch is kind of what we're going to start talking about here, okay? So the length is always to the right. In this case, it's showing you a 12-inch weld. It does give you the dimension of where it has to start. We're not a center-to-center pitch yet. It's just telling you it has to start 3 inches from the edge. It is a full-length weld of 12 to 12 from start to finish, okay? Here is a closer one. So now we're going to start talking about pitch to pitch, or length and pitch. So it's going to be a 3-inch weld every 6 inches. So if you notice, the weld, the pitch is considered center to center. Length of the weld is from end to end, okay? And in this case, usually it will tell you a set-off spec as well. So if you start 1 inch in, 3 to 6 afterwards, okay? Usually this set-off distance is not going to be on your print. It's going to tell you to see the detail or the view, right? Whichever view, it's either the ISO, the right, or the top view. That's going to give you that dimension whatsoever. Biggest thing, center to center of the weld. Okay. Chain intermittent and staggered intermittent. So we just talked about the big Navy shipyard chain, and the way that I think about a chain intermittent is exactly like that. I want you to think of these chains. So these two welds make a chain. This chain is sideways. These two welds make just like a chain sideways, and the links are smashed together on the outside. That's how I think of whether it's a chain. That's how I distinguish the difference between a chain intermittent weld or a staggered intermittent weld. Now, the staggered ones are individual in between each other, okay? In this case, you don't see them where the links sandwich, they're staggered. This one looks more like an actual chain intermittent weld. Same thing, just like we did earlier, it shows you just like a fill weld, length and pitch, okay? Length of weld first, pitch comes later, center to center weld. In this case, staggered intermittent welds, they're all 3-inch length, they're 10, but if you notice, look at this, it tells you which one starts left, and they are, that's the way you tell if it's staggered versus chain. Straight up and down is chain, staggered, they are offset, okay? And it will, this one, and then